So next up, we have Nick Huntington-Klein, who is an assistant professor of economics at Seattle University. And today he will talk about the influence of hidden researcher decisions in applied microeconomics.
All right, hello.
Hi there.
Hi.
Welcome. Take it away.
All right, so this is one of those papers where you can sort of guess what we're going to do by just how many authors there are. So this is going to be a paper where we're going to be doing some replications, right? So we got a lot of authors. I'm not going to go through everybody; it's too long to list. But this paper is about hidden researcher decisions, specifically an application to applied micro, and I'll get a bit more into what exactly I mean by that. So we've all done research if we're on this call, and you know that as you're doing research, you're not just making the decisions that you write out in the paper. Right? In the paper, you say, here's the model that I'm going to run, here's the data that I'm going to use, I maybe drop these people, but there's a lot more decisions that go into it than that. And that can be things like, okay, the definition of particular variables. How do you decide how to bin a particular continuous variable? Lots of different things that are available there. So, and this can go all the way from data cleaning through sample selection. Which software commands do you use? Are you going to, if you're working in Stata, are you going to run your fixed effects regression with AREG or XTREG or REG-HDFE, right? And then sometimes they make slightly different results. So the real problem with this is that a lot of the times there's not a single correct answer for whatever choice it is that you're making, right? So if, for example, someone was to go back through your code and try to replicate it, they might well be able to replicate your paper. They might well go through it and say, okay, yeah, this all looks fine. I don't see any problems with your code or your analysis. It seems okay to me. Maybe I would have made a different decision, but it seems fine. And so because we have multiple different ways that we can do something and have it mostly be accepted, I'm going to call that a researcher degree of freedom, right? So the researcher has some freedom in terms of how they're going to do their analysis in a way that would be accepted in multiple different ways. So some of these choices that you might make are going to be visible to people who are reviewing the paper, right? So if there's somebody who is, refereeing the paper for publication or going back to replicate it later, but others are going to be a little bit more hidden. If you are just reading the paper, there might be some stuff that's only visible in the code. If you're reading the code, there might be some steps to the code before you get to it. If you go into replication files, a lot of the time you will find that there was some data processing done before you get to the data set that's available in the replication files. And so if some of these invisible and seemingly unimportant and potentially correct decisions matter, then we're going to be in trouble, right? It's going to make us a little bit more skeptical about how believable maybe some of the results are. So what we're doing in this paper, we're using a many analysts approach. You might have seen some many analyst approach is in some other fields. There's one in neuroscience with Colin Kammerer on it. There's one in political science that looks at by Silverzahn. There's some other stuff outside of academia entirely. But what we're doing is we're taking a small number of studies and we're replicating them many times each. Okay, that's the idea that we're going here. So we're not going to take a bunch of studies and try to see how replicable all of them are. We're going for a small number of studies, but multiple replications of each of them. What we find in this many analysts approach, which is consistent with what other many analysts approaches find, is that there are large and apparently invisible differences in data cleaning. Sorry, I guess I should say this is something that we're doing differently from a lot of these other multi-analyst designs, that we are also allowing our analysts to clean the data. We're not providing them with a finalized data set and letting them just pick the model, but we are also letting them clean the data as well. So we see differences in data cleaning. We also see meaningful differences in analysis, and we'll get into the specifics of all that. If you want to take away a single sort of headline number from it, the standard deviation of the effects between different researchers is about 3 to 4 times the reported standard error in those replications. So there's a bunch of variation in our research that is due to these good faith, non-publication bias affected variation in these effect sizes. So we find a bunch of degrees of freedom. We find a bunch of differences in what people can do. Anytime that a researcher could make a choice one way or another, that's a degree of freedom. This might be a mistake, but it also might not. This is distinct from p-hacking or publication bias because in this case, all of the analysts knew that their results were not contingent on finding significance or anything like that. It's also not the garden of forking paths. If you're familiar with that, that's the basic idea that there's so many different choices to make that the distribution across the sample, across the population space is very large, and you're likely to just find one by either trying multiple things or just happening to go far enough down the path that that you find something that's not representative of the overall. So we're focusing on different ways researchers could perform this exact same analysis. So we are going to give them the exact same goal in effect. We're going to see how they approach that goal differently. So they have control over data cleaning, model selection, the creation of control variables, selection into the sample, all that sort of stuff. And as I'm going to show you basically the data, right? Nothing in this particular paper is particularly complex. I'm basically just going to put the data on the screen. And what I want you to think about as we're going through these is to think, okay, if I saw one of these replications, if I saw one of these as the study, would I have made those choices in the same way? And also, if you would not have made the choices in the same way, if you were refereeing a paper who had made the choices that way, would you have even commented on it if you were refereeing it? Also, would these choices make it into a write-up of the study, right? If we were actually writing a bunch of different papers with all these replications, then would it be listed in the data section that you were, say, defining an educational variable in a particular way, or dropping a part of the sample that is typically dropped? For example, if you look in current population survey data, they have a group quarters variable that is for people who are living in group quarters. A lot of analysts will just drop this entirely and not mention that they've dropped those observations in the write-up because it's just so standard. And so some of our replicators did that, some of them did not. Would that have made it into the final write-up? So I mentioned there are some other many analyst studies. I mentioned one in neuroscience by Botvid and Gnezer. They give the same set of neuroscience brain imaging data to a bunch of replicators. They use different methods, they find different results. The support of a bunch of different hypotheses varies significantly across teams. Silberzahn looks at soccer penalties. So whether they can find racial discrimination in red card and yellow card penalties in soccer. Again, very different methods, very different results. Outside of academia, Cone 2016 gave the exact same poll, presidential poll from the 2016 presidential election, to 5 different pollster companies. And based on the way they weighted the data, they came to very different conclusions about the margin of that poll, who had won it. So some people said that exact same poll favored Hillary Clinton. Some said that it favored Donald Trump. But all these really focus on differences in the analysis portion of the show. So they provide a cleaned data set, and they allow people to make differences in analysis choices. We are also going to allow the data cleaning stage to be different as well. So what are we doing specifically? We have 2 different studies in applied microeconomics. We recruit a set of researchers who are going to replicate each of these studies. All they know, the information that they are given, is that they have the raw data set that we use. They're told where to download it from. We give them identifying assumptions. These are both studies that provide causal identification. So they have causal effects. So you have to make some assumptions about that. We are providing them with specific identifying assumptions that will allow them to make those estimates. And then the research question itself. And everything else is a degree of freedom. Everything else that you want to do, however you want to manipulate or clean the data, how you want to construct your model, is up to you. We tell them to basically do the analysis and data cleaning as though they were the ones who had come up with the idea and were writing the paper. And this is blind, so they don't know the studies that they are replicating. What did we do? We wanted to select 2 studies. We wanted well-regarded studies, but that were not so famous that people would recognize them when they were replicating them. We also wanted them to have publicly available data. And then we wanted the research design to be simple enough that we could get people to, we could communicate what the idea is of the paper without just telling them what to do. So what we ended up with were 2 papers. The first one is Black, Devereaux, and Salvanis. This is looking at the effect of compulsory schooling on teenage pregnancy. So if your state raises the age at which you have to stay in school, is that going to make you less likely to have a child as a teenager? They use decade by decade and state by state variation in the United States in compulsory schooling laws with census data, and then they look at how that relates to teenage pregnancy rates in those states. They go further than that, than just looking at the effect on teenage pregnancy. They do something with the incarceration effect. We're not going to do that. We're just going to look at the one effect of increasing the compulsory schooling age from 15 to 16 and see whether that affects the chance that somebody's going to have a teenage birth. The other one is Fairley, Kapur, and Gates, which is in the Journal of Health Economics. This is looking at the effect of health insurance availability on entrepreneurship levels. So basically, in the United States, you turn 65, you are now eligible for Medicare. And so this allows you to get health insurance not through your employer, which is something that happens at that age. So the question is, are you going to take that health care and then go become self-employed and then start a new job because you can now have both health insurance and a small business? So this looks at the current population survey. And in the current population survey, you're surveyed 4 months in a row, and then there's a break, and then there's another 4 months. So you have two different sort of 4-month stints. And what we say is, okay, we're going to look and say, if you turned 65 inside of one of those stints, we're going to look at you before you turn 65 and after. And did you become self-employed in that jump there? And so, it's a very small T rolling panel because we have a bunch of different people. The timing window changes, but we see each person for 4 months in a row. So this is a very simple version of what they did. We're just comparing people who just turned 65 to people who are not quite 65. So we're looking at the effect on self-employment within just a couple of months. So we have our studies. We need to recruit people to do these replications. We did it in two different ways. We emailed the department chair of every major United States econ department and asked them to pass the message on to their faculty or just the applied micro faculty. We also posted a recruitment message on Twitter, which was clicked 638 times. I don't know how many department chairs passed on the information. The idea is that we want replicators who are going to be representative of people producing applied microeconomics work. So we wanted people who are published in applied microeconomics, or at least are forthcoming or have some upcoming work in it. And we wanted them to produce replications as they normally would. So if they use, say, graduate assistants to do the work, we wanted them to continue to do that. We got 49 people signing up. 12 of them actually finished the task. Most of the people who did not finish said that basically they thought they had the time and then didn't. Nobody cited, I looked at the thing and it was just more than I expected it to be. So I didn't want to do it for that. It was pretty much just time constraints. I mean, I mean, you've tried to get people to do stuff. You know how it can be. We compared the observable characteristics, publication record, topic alignment, confidence of finishing between people who did and did not finish. We didn't really find any differences. Obviously, that does not account for selection into the volunteer sample in the first place. All right, so let's just get into what we found. So first, let's look at the teenage pregnancy study. Again, this is looking at the effect of compulsory schooling on teenage pregnancy. And we have 7 different replications. So I mentioned we had 12 replicators. Some of them completed more than one replication. So we have 7 of each of the studies. And you can see quite a spread of the effect sizes that they found. So it's roughly centered around 0. We see both fairly strong negative and fairly strong positive results. Some of them are significant negative, some of them are insignificant, some of them are significant and positive. That's some pretty big differences, right? This does not look great for the teen replication study that we have there. And so we can also look at the specific choices that they made. So the nice thing about this, I don't need to squish this nice table down into a slide size, but this is looking at the different choices that were made. So everywhere there's an X, a particular choice was made in a particular replication. So there's some things that are all shared, right? They all got data from where we told them to get data from. They all use just adult women. Most of them used women ages 20 to 30, as we said. Everything with a star next to it, we told them to do. Everything without a star is a choice that they made on their own. So we can see, for example, people living in group quarters. Somebody dropped those people. Others did not. We have whether they drop women who never have children, and they're just comparing people who gave birth between when they gave birth or didn't, and everybody else was comparing, did you have a kid at all at age 18 versus not. And so there's a bunch of other limitations. I do want to point you down here to the sample size used in estimation, because these different data cleaning steps, these are all data cleaning choices, led to very different sample sizes. And in fact, no 2 studies had the same sample size. They all differed. And so you can see the range of sample sizes. The smallest here is 831,000. All the way up to the largest, which is 4.2 million. These are pretty different, right? So, and even the ones that are similar are not exactly the same. So there's some difference going on between the person who has 1.7 million and 1.696 million. right? So there's clearly some differences in data cleaning. We don't all agree on the same way to clean and prepare data for a model of this type using the same data. We can also take a look at, the Zoom bar is covering me, the analytic choices. So this is, if you're an applied microeconomist and you were looking at this research design, you would think difference, or at least something very similar to it. And pretty much all of our replicators came to a similar idea where they are using a two-way fixed effects model. It's not strictly difference, but it's similar. They're using a two-way fixed effects model with state fixed effects and some sort of time control variable, either birth year fixed effects for when the potential mother is born, or year fixed effects or age fixed effects. One of those, so that you're isolating the change in the compulsory schooling rate within a given state, while controlling for time trends. There's not a whole lot of different choices being made, but there are differences across the different replications. You know, did you use sample weights? Economists tend to be guilty of not using sample weights a lot. You can see that right here in terms of about half of our sample using the sample weights and half of them not using the sample weights. Some of them one of them limited it to just people who are the spouse of the household head. Some of them used state-specific time trends. Some of them did not. Right? So there's lots of differences here. And you know, so for both of these tables, we are looking at all these different choices and also how much they affected the actual outcome. So we also redid all of the replications while either making the analysis consistent and looking at just the effect of the data choices, or keeping the data set consistent and just looking at the effect of the analysis choices. So what we find is here, you can look at how the similarity, the coefficients don't actually get that much more similar when we hold the analysis constant and let the data choices differ. They look pretty much the same in this last row as opposed to the second to last row. So in the case of the teenage pregnancy survey or study, it's mostly down to the differences in data cleaning. So the differences in analysis, which are the ones that would be more likely to show up in a paper, were not actually as consequential as the data cleaning choices that might be less likely to show up in a paper. Let's go on to the second study. So this is the health insurance study. This one was a lot more consistent, a little bit less of a concern with the health insurance study. This is again looking at the effect of health insurance availability on in entrepreneurship rates. Very similar range of effects, and you can compare that to the original study, which is also in a pretty similar range. The 95% confidence intervals are always overlapping for these. This is sort of an outlier over here, but that's the only one. We do see differences. Some of these studies would have reported significant results. Some of them would have not. But we don't see it quite as much of a difference. That said, we do see very big differences in the data cleaning. So this is a case where the replicators, in some cases, we talked to them about why they did this. Some cases they made an active choice to do this. In other cases, they did not. Where we told them to limit the data just to people who were observed turning 65 in one of those 4-month windows. But a lot of the replicators went beyond that and included, say, everybody from age 64 to 66, or everybody from age 60 to 70, or everybody from age 54 to 76, right? So they used a much bigger range of people. And so that was a big difference. That was responsible for most of the difference in the sample sizes. You can see these sample sizes vary wildly. We have 1,600 all the way up to 156,000. That is a lot of that is due to the differences in the age ranges that are included. But even once you get rid of the age range issue, still you have no two sample sizes being the same. We also have point estimates. Like I said, they're very similar. If we force the model to be shared, we see again that it is not really the analysis choices that are doing this. Got it. Thank you. It is more the data cleaning choices. The analysis choices are a bit more all over the map here. This is very similar to a regression discontinuity design type paper, albeit one with only 2 periods before and 2 periods after, so a very short one. And so that was what a lot of replicators saw as well. Some of them explicitly did regression discontinuity using different kinds of polynomials. Obviously, the ones with bigger polynomials were the ones with bigger age ranges. You can't really do that with only 2 periods before and after. Some of them did what is in effect a regression discontinuity by just comparing above to below. That's basically a 0-order polynomial regression discontinuity. But then there were also a lot of differences. Did you use probit or logit versus a linear probability model? Because the outcome is entrepreneurship, it's binary. What kind of standard errors did you use? Did you cluster them? Did you use robust standard errors? What command did you use? Three different stated commands, one R command. Did you use sample weights? Again, economists not really using sample weights being evident here. We also saw lots of differences in the controls that were included in the health insurance study, and also how those controls were constructed. So we said some people didn't include any controls at all. That person, when we asked them, they said it's a regression discontinuity. It shouldn't need controls. If it does, then you're probably doing something wrong. A lot of education controls, but a lot of differences in how that education variable was constructed, right? We've all read a regression table that says controls for education. Yes, right? But what does that mean? Is that every year of education? Is that a linear term for education? Is that 4 different categories of education? Is that all different categories of education, which I believe is 13? Is it 2 different categories of education, right? The construction of this, taking this categorical variable and binning it into something you can use, that's a choice that we make that often we might not pay that much attention to when we are reading the study. All right, so what we have in both of these studies, there were very big differences in data cleaning, which is something that has been ignored before in these multi-analyst studies. And also no 2 of them had the same sample size. No 2 replications had the same sample size in any of these. So that seems like a potential problem. There was also big differences in the construction and selection of controls, which we would probably pay attention to what is being controlled for, but in terms of the construction of those controls, maybe not. And a lot of these differences that we have, especially on the data cleaning side, might be unlikely to be reported in a write-up, even if they are going to be in the code, in the replication code, how many people read that code? And also, if you saw it, again, would you consider it a mistake that you would want to point out, or would you just be like, well, I guess that seems reasonable? Because if it seems reasonable, well, it looks like there's a bunch of different reasonable ways to do things, and those different reasonable ways can lead to different sample sizes, which in one of these studies led to very different effect sizes as well. Now, thankfully, this only really mattered that much for one of our studies and not the other. One of our studies, we had this big range of effects. The other one was very consistent, although the significance did vary from replication to replication. But we don't know which of those 2 studies we're doing when we are doing a given study. So we have lots of different choices that researchers make that don't have a right answer, but get written up, and might not get written up, but do matter. We are not well set up to check this stuff. Replication studies don't really get at the issue because, again, if they would replicate, and if you ran their code again, and you might look at their code and say that is a reasonable choice to make. If you are doing a pure replication, you might make that choice in the exact same way based on the cue that you've been given that they have done it as well. A lot of this points towards data cleaning and data availability, that a lot of these different choices are being made at that level. Which suggests a couple of things. One, if you're doing replication files and you're uploading them, it's probably a good idea to go from the raw data and include that first data cleaning step if possible. Also, there are a number of data sets that are pre-cleaned, and that would be one way of getting at these issues. So for example, for the current population survey data here, we have them go from raw data and clean it themselves. A lot of people might go from, say, the NBER merged outgoing rotation group files, which are to an extent pre-cleaned. Having a shared cleaning method that everyone has followed because it is pre-cleaned, IPEDS is another good example of this, is likely to cut down on the variation between different replicators in terms of how the data is treated. On the analysis side, we are more familiar with ways of handling this problem on the analysis side, things like model averaging, paying really close attention to the study, replicating the study, trying different assumptions, trying different models, all that sort of stuff. We're a bit, it's still a problem, but we are more familiar with ways to solve it. And just generally, when we are reading a paper, we need to be aware of this additional source of variation that we are not really accounting for. There's variation based on these differences in reasonable choices that you could make. And we find that the standard deviation in both papers, the standard deviation of effects is about 3 to 4 times the reported standard error, which is pretty big. And we're leaving that variation out of our understanding. All right, that is it. I'm happy to take some questions.
Thank you, Nick. That was great. If anyone has any questions, please post them in the chat, and then I'll relay them to Nick, or you can just unmute yourself and ask your questions right away. And we have about 4 minutes, I believe.
Yeah, I mean, I'm torn on this question, but I'm just curious if, so when they're reporting effects, they should verbally, or they should give a sentence that says a change of this much in X creates a change of this much in Y. And so if there's scaling differences, when you present the variance or standard deviation or whatever, it's, I wonder if it's misleading. Then again, there's this thing that, well, we should just treat their effects as what they gave us and take their metric. But yeah, I'm a little torn because you're maybe comparing things that aren't comparable, or I don't know exactly what you did.
So the nice thing here is that because they're replicating the same studies, the scale of the outcome variable is always the same. In the case of the second study, where some of them did probit logit and some of them did OLS, we converted all the probit logit into marginal effects before reporting them and comparing them.
Nick, when you were saying that when you basically told them to replicate the paper, you told them to replicate the entire paper, a specific specification within the paper.
So we had them replicate a single specific result in the paper. So, and we picked it out for them, right? So it's one estimate, a single estimate in each of the papers. And it doesn't actually exactly represent what the original study did. So these are not good measures of whether the original study can replicate, because we did change the stuff a little bit to make it more amenable to the process here. Yeah, it's only one estimate in each case. And we also, I should have mentioned, we also told them not to do a bunch of robustness tests. We told them to pick the one version of the estimate that you would consider the main result that you would put in an abstract, right? If you were going to list a number in the abstract, which result would you list?
And did they have access to reproduction materials from the original authors?
No, so they didn't even know what the original study was.
Ah, so you gave them like a claim, like a sentence or something.
Yes,
like
yeah.
that.
So what we gave them was,
okay.
We said, here's your research question. Does compulsory schooling increase teenage pregnancy rates? Here's the data that you're going to work with. You're going to work with the census data. And here's your identifying assumption. And then we laid out the identifying assumptions that would allow you to reasonably estimate that.
But this study is quite well known, no? Did you ask them if they knew or if they have an idea of, I mean, they know it's a replication exercise, and I knew that study right away when you just mentioned,
So that was a concern. That was why we made sure to steer clear of like AER papers or things like that. In the case of the teenage pregnancy paper, we figured there were enough other studies that were sort of like that they might not know which one it was, and probably something similar. There's a number of studies that use that sort of Medicare cutoff. We did ask after the fact, did you recognize the study? One of the replicators recognized one of the studies, but that replicator's results were not meaningfully different or were more similar to the original study than the other replicators.
Okay, good.
And one question. So given that you're giving them sort of the hypothesis to test, and you're implicitly or explicitly describing the levels of the outcome variable. Mm-hmm. How are you sure that everybody would construct the outcome variable the same way?
So we checked their code. We walked through their code line by line to see what they were doing. And some of them didn't. So in the case of the teenage pregnancy paper, for example, one of the replicators excluded people. What was it? Included people who had a birth by at age 18 exactly. Whether or not that counted as a teenage pregnancy, there was difference across the replications. Similarly, we told them to drop women with who had given birth at age 14 or below. One person dropped women who had given birth at age 13 or below. One of them dropped women, or said included women with 14 or below, but just didn't count them as being teenage pregnancies. So there was difference in the outcome variable, and that is one of the sources of variation.
Okay, and one last suggestion I would say, or something I would like to see, is that this type of the table that you have there when you show the different specifications, it's like a subset of these specification curves that are more popular in psychology, but are becoming somewhat popular in economics. I think it would be very nice to see where those choices map into a larger specification curve, because when you see a specification curve, you don't know how reasonable are all these choices. What you have here are what you will define as quote unquote reasonable choices. So maybe you through a specification curve you get a result that's saying that there's a lot of variability, but through a subset of a specification curve with reasonable choices, you get a different result. I don't know.
So we did try that. We tried to do that. And the problem that we ran into is that a lot of these, you can't just change one thing at a time. For a lot of these, some of these choices are mutually exclusive with each other. Some of these choices are, they interact in strange ways. And so it's difficult to just sort of line them up and say, okay, we change this thing, then we change this thing, then we change this thing, and combine them all. So we figured that we could do it, but the number of different specifications was going to have to be so enormous because there's basically 2 to the power of, however many there are here.
Yeah.
It would have been too big to really make much sense of, we thought.
And I'm sorry, we're gonna have to interrupt the discussion because we're at time. Thanks for your presentation, Nick.
Well, thank you very much.
Thank you to also to Nate and to Abel for sharing their work today. So right after this, we're gonna close out this room and we're gonna bring you everyone into the plenary, and then we're gonna disperse all of you into like breakout room discussion. So you can take. We're gonna have about 15 minutes. You can take those 15 minutes to chat with others that you're gonna end up in the breakout room with, or you can just take these 15 minutes to just actually take the break. So thanks again to everyone, and let's just try to migrate back into the plenary now.
Thanks.